Hi there, and welcome to this lesson. And this lesson we're learning about logarithms, okay? And under logarithms, we'll be learning to use logarithm tables. Interesting. So, at this point, I'd remind you to set the video to play in 1080p HD. Very important that you do so. And as the lesson progresses, if you have any issues at all, anything comes off as unclear, please feel free to get in touch. Okay, you can do so via the course dashboard. Okay, let's jump right into the lesson. So logarithms, using logarithm tables. Now, what are logarithms exactly? What are logarithms? Now, the logarithm of a number is the power to which 10 is raised to give that number. Interesting. So, for example, if I had log of 100, okay, log of 100 is the number that I would raise 10 to give me 100. And what number would I think 10 to the power of 2 will give me 100. So I can say that log 100 equals 2. Let's do another one. So what about log of 1000? Now log of 1000 is 1000 is 10 to the power of 3. Remember, the logarithm of a number is the power to which 10 is raised. Okay, so whatever number you raise 10 to give that number is the logarithm of the number. So what number would you raise 10 to give 1000? You would raise 10 to 3, okay, because 10 to the power of 3 is 1000. So the logarithm of 1000 is 3. It's that simple. Very, very simple concept. Now, we can also find, basically, we've been doing the easy ones. So log of 100, log of 1, these are multiples of 10 or powers of 10, basically. But then you can actually find the logarithm of a number that is not a multiple of 10. For example, the logarithm of 4251. Now, to find the logarithm of 4251, we need to use logarithm tables, and that's what this lesson is about. Okay, so we need to use logarithm table, and this is what a logarithm table looks like. Okay, so you have log of x, and you have x 0 1 2 3, and you have differences, and then you have some funny looking numbers there, but we'll get to that in a sec. So now, to find the logarithm of a number using logarithm tables, there's something we need to do first. Now, we have log of 4251. We need to express 4251 in standard form. So we have log of 4251 as log of 4251 times 10 to the power of 3. Now, times 10 to the power of 3. We're going to write this down, write this 3 down, the 3, and we say point. Okay, just watch, follow closely. We have 3 points. Now, when you express the number in standard form, okay, you have 10 to the power of something. Now 10 to the power of x is the whole number of the logarithm. Okay, it will all get clearer in a second. Now that you have 3, we're now going to use 4251 to get the rest of the numbers, because we're actually going to get 3 point something. So we're going to use 4251 to get the remaining numbers, the decimal places. Okay, the numbers in decimal places. Now you look at your logarithm table, okay, and the number is 4251. Now this is an basically we extracted this from a logarithm table, and normally if you look at a logarithm table, you actually have a lot more rows than you have here. We just have one row. We have the row for the number 42 or 42. Now, and basically you're going to use this to find the log of 4251. Now, to find the log of 4251, you say 42. This is how you read it. 4251 is the number. You say 42 under 5 difference 1. Okay, so we have, the first thing we do is we have x, and then we look for 42. Okay, we look for number 42, that's row 42. Okay, and then we look for the number under 5, and in this case we have 6284. Okay, and then we have 4251. The last number is 1. Okay, difference 1. Now let's go over it again. First, you convert the number to standard form. You express the number in its standard form. Okay, and then you write down the power, the 10 power, as your whole number. And then to get the decimal place, you basically look at the number itself, that's 4251, and you say 42, okay, under 5, difference 1. Okay, and when you do that, you have 42 under 5 is 6284. And where does the difference come in? Now the difference, the number you have under the difference 1 is 1. In this case, you simply add 1 to 6284, and what you have is 6285. So the log of 4251 is 3.6285. Now, if we're trying to, what if we're looking to go back? Okay, so we're given the logarithm of a number and we're told to find that number. Okay, so let's say and some we call this antilog, and it's often written as log inverse. Okay, log to the power of -1 of a number. Okay, and it simply means 10 to the power of that number. Now we basically have 3.6285, and we want to take this back. So we know that log 4251 is 3.6285. We want to take this back, okay, and get 4251 again, and we can do so using anti-log tables. Okay, now the first thing we do here is basically we have 10 to the power of 3.6285 equals something times 10 to the power of 3, because our whole number in this case is 3. Okay, if you remember, basically we had the whole number from the standard form, the index from the standard form as our whole number. Okay, so we just take that back and we have our whole number in this case as the index of 10 with the number expressed in standard form. Okay, so 10 to the power of 3.6285 equals x times 10 to the power of 3. Now we're looking for x. Okay, we're looking for a number in its standard form that will multiply 10 to the power of 3 and would give you whose logarithm is 3.6285. Okay, now what we do is we have 3.6285. we look at 6285, so we're basically looking at 62 under 8 difference 5. Okay, and 62 under 8 is 4246, and difference 5 is 5. Okay, so we had 4246 plus 5, and what we have is 4251. We can go and write 4251, and remember we express this in standard form, so write this as 4.251. so x in this case is 4.251, and we have that 10 to the power of 3.6285 equals 4.251 times 10 to the power of 3, which equals 4251, i.e. our number in the first place. So we've basically learned how to find the logarithms of numbers using logarithm tables. I've also learned to find the antilog of numbers, i.e. reversing the logarithm process using antilog tables. And now we're going to go ahead and solve some examples. So we have example 1, and example 1 says find log 23.69 using logarithm tables. And to do this very simply, the first thing we want to do is we want to convert 23.69 to standard form. Okay, so we have the log 23.69 equals log 2.369 times 10 to the power of 1. Okay, so now for our logarithm, we already have our whole number. Our whole number in this case is going to be 1. Now we want to find the numbers in the decimal places, and to find the numbers in decimal places, we make use of our log table. Now we go back to the actual number itself. We have 2.369, and we're going to use that number on our logarithm table. So we have 2369, and what we're doing is going to find 23 under 6 difference 9. Okay, so we have this, we already have 23 here, so 23 under 6 difference 9. Okay, and basically difference 9 in this case is 17, so we have 3729 plus 17, and that should give us 3746. And basically we have the log 23.69. remember our whole number we had times 10 to the power of 1, so our whole number is 1.3746. and that is log 23.69. It's actually very simple. Let's do another one. Now, it is worth mentioning that you can find logarithm tables in four-figure tables booklets, okay? Or you can pretty much find them anywhere on the internet. So you just Google logarithm tables and you should have them there. Or they're often in your textbooks as well. You'd find the full logarithm tables where you have logarithm numbers for all, pretty much any number you're trying to find, okay? And let's do this one now. So we have find the log of 0.002834 using logarithm tables. Now, how do we go about doing this? First thing we need to do, we need to convert to standard form, and we have log 5.834 times 10 to the power of minus 3. So we have our whole number for our logarithm, and our whole number is going to be minus 3. The next thing we want to do is we want to find the numbers in the decimal places, okay? And to do that, we use our logarithm tables. So the number we're considering this time is 5834. So we're looking at 58 under 3 difference 4. So 58 under 3 difference 4. So 58 under 3 is 7657, and difference 4 is 3. So I can go ahead, if I add 3 to 7657, I would have 7, I think you'd have 7660. Okay, I think I can go ahead and say that the log of 0.005834 is bar 3.7660. Bar 3 is the same as minus 3. Okay, so we write it as bar 3 because it's just the whole number that's negative. Okay, it's just something very interesting we're doing logarithms. Okay, it's just the whole number that's negative. 0.7660 is actually positive. Okay, so we often write this as bar 3.7660. You don't write this as minus 3.7660 because that would imply that the whole number is negative. But just for logarithms, okay, we have a number that's made up of a negative whole number and a positive decimal number. Okay, so that is that. Okay, the log of 0.005834 is bar 3.7660. Okay, let's do one final example. Example 3. And example 3 says find the antilog of bar 4.4319. Okay, so we have 4.4319 as a logarithm of a number, and we've been asked to find that number. Okay, so the first thing we want to do is we have 10 to the power of bar 4.4319. Okay, and this equals x times 10 to the power of minus 4. Okay, so we consider the whole number there. The whole number there is bar 4, which will tell you that this number, the antilog of this number would be a number in a standard form times 10 to the power of minus 4. Now we're going to apply our antilog tables, okay, and the actual number we have in this case, we consider the numbers in the decimal places. We have 4319, okay, and we can go ahead and say 43 under 1 difference 9. Okay, so 43 under 1 difference 9, and you have 2698 plus 6, and when you work that, you'd end up with 2704. Okay, 2698 plus 6 is 2704, and what you have is 2704 times 10 to the power of minus 4. Okay, and that would equal 0.002704. And that is how you find the antilog of numbers using logarithm tables. It's actually very simple. There really isn't much to it. And yeah, bye for now.